Well, this is an exciting step. We're going from our work in flowcharts to formal sequencing when solving equations. Let's look at a couple of examples and analyze what's going on. First of all, we've got 3x plus 9 equals 45. And what we would normally do with the flowchart is to put in our x and build the expression up. The first thing we need to do is multiply by 3. We have 3x in the middle box at the top, and then we need to build our expression by adding 9. So we have 3x plus 9 equals 45. I didn't quite fit in the box there, did I? So I've written the formal expression below the equation, and we're going to move to what you will be doing. You won't be using the flowcharts anymore unless you need a bit of support, and please use the flowcharts anytime you need a set of training wheels, you know what I mean? You've just got to take this gradually. Some people will get quicker than others at going from the flowcharts to the actual equation, but your end goal should be to solve it formally with a vertical sequence. Okay, sequence is a bunch of steps. Okay, so what do we do when we're working vertically? This is our goal. Well, let's think for a moment what we would do if we were backtracking. So 3x plus 9 equals 45. We would use the inverse operation of plus 9, which is minus 9 in our backtracking. We also do that with our solving formally. Okay, so we go 3x plus 9, which is what we had, and then what did we do? We minus 9, so I'm going to minus 9. Now think about our scales or our seesaw. We must remain balanced. Okay, what you do to one side you got to do to the other to keep that equation balanced, which is a bit like the seesaw or set of balances being horizontal. So what did we do? I put it in red. We minus 9, so we must do that to the right hand side as well. So let's minus 9. What did we have there? 45. We need to minus 9, so I better stick to my consistent colouring. Minus 9. Why? Because it makes it simpler. We're in our journey back to the solution. 3x, because plus 9 minus 9 is 0, so we have 3x plus 0, which is just 3x. 45 minus 9 is 36. Now if you think about it, when you were doing the flowchart, you would go 45 here minus 9, and you'd also get 36 there. That makes sense. So you can see this 3x equals 36, and look at this line, it says the same thing. So it makes sense, doesn't it? Next, remember, if we were using the flowchart, we would undo the times through with the inverse operation, divide by 3. 36 divided by 3 is 12. So the solution should be 12. Well, how do we do that formally? We go 36, and remember we divided by 3. So let's do that to both sides. And we have on the right hand side 36, and we divide by 3. Change to red, and let me get rid of that arrow, and look, we have times 3, divide by 3, cancel each other out. We have x, 36 divided by 3 is 12. That's our solution, x equals 12, and it matches. So I don't want you to do both methods now. I want you to move from the flowcharts gradually to the formal setting out. Let's look at a slightly more difficult one. So we know if we were using a flowchart, we would have to build the expression up first. So building it up, we start at t, go to times by 7, which means on the way back we'll be dividing by 7 when we backtrack. Then we need to minus 9. Remember, we work inside the brackets first, which means we need to, on the way back backtracking, we need to add 9. And lastly, we're looking at outside the brackets, Now you can see on the front there's a negative 4. We times, that's a times, isn't it, when there's no symbol? Times by negative 4, which means on the way back we divide by negative 4. So let's build the expression up now. Need to change the black font. So t times 7 is 7t. 7t minus 9, because we minus 9, and then we've got negative 4 outside of 7, t minus 9. All of that equals 80. Alright, so you can see that I've written it down there just a moment ago, formally. Now remember, what do we do first? We look at the backtracking. What would we do first with a flowchart? We would divide by negative 4 first, because it was the last thing we did when we built the equation. Remember from all our work, you backtrack in the opposite order in which you built the equation. So you have to understand how the equation would have been built. That's a huge thing to remember. If you can remember that and remember to reverse it with inverse operations in the opposite order, you'll be fine. You'll always be able to solve linear equations. Great, hey? So let's do that. We've got to divide by negative 4. Okay, bit of writing. Students love writing lots of things. They really love it. Here we go. So we've got to divide both sides by negative 4. What you do to one side, you've got to do to the other. So we'll be dividing by negative 4 on that side as well, won't we? And we've got 80 there, so it's 80 divided by negative 4. And we get negative 20 there. And divide and times by the same thing just leaves us 7t minus 9. So we have 7t minus 9 equals negative 20. Alright, and if we use the flowchart we would have got that too, because we would have got negative 20 there. Next thing, we have to add 9. You can see that on the flowchart. So we have 7t minus 9, and we have to add 9. Do the same thing to both sides. So we'll be adding 9 to this side, and negative 20 plus 9. Let's simplify that now. So that gives us 7t equals negative 11, and we can see that we've added 9 to both sides. And if we look at what we would have done in the flowchart, that makes sense, because you can see we have 7t equals negative 11. And looking at the flowchart, what do we do in the final step? We have to divide by 7, because that was the first thing that was the first step we did when we multiplied by 7. It's the last thing to undo if we divide by 7. So we have to do divide by 7 to both sides. So we have 7t divide by 7, and we'll have to do that to that side. Divide by 7, same thing. So we have negative 11 divided by 7. Negative 11 divided by 7. On the left hand side, that's good. We have times 7 divided by 7, cancel each other out, which is just leaving 1t, or just t. That's going to be the solution. Ooh, what do we do with this? Well, you can leave it as negative 11 on 7. It's an improper fraction and it's simplified, so that's fine. Don't let anyone tell you improper fractions are no good. That's fine. It's simplified. You can't, they're prime numbers, you can't divide it down. If you really have a hankering for a mixed number, well, it's negative 1 4/7 if you like. Let's try some formal sequencing.